The broadcast begins not with a whisper, but with a call to attention. Welcome to a story not of comfort or sleep, but of scale, mystery, and relentless motion. This is not merely a stargazing journey. This is an urgent investigation into the colossal system that defines our cosmic home, the Milky Way galaxy. For more than 13 billion years, this spiral of stars, gas, dust, and hidden mass has turned quietly above us. Tonight, we peel back the veil and uncover not just beauty, but danger, history, and destiny. The galaxy you live in is not a sanctuary frozen in time. It is a dynamic, violent stage, an arena of collisions, upheavals, and ancient survivors. To imagine the Milky Way as peaceful is to misunderstand its very essence. It has devoured galaxies before, and it will collide again. In fact, it is colliding as we speak. The Sagittarius dwarf galaxy, once independent, is now being torn apart. Its stars stretched into faint streams that wrap like scars around our galactic disk. Astronomers mapping the sky have found these trails, stellar highways that tell us the Milky Way is a cannibal, a predator that survives by consuming the weak. And yet, this predator is itself vulnerable. 2 million light-years away, the Andromeda galaxy is on a slow but unstoppable approach. At 110 kilometers per second, it closes in, destined to merge with us in approximately 4.5 billion years. What will that look like? Not chaos in the way of crashing stars. Space is too vast for that. But gravity will twist both galaxies into warped arcs, luminous tails stretching for thousands of light years. Black holes at their centers may spiral together, fusing into something even more monstrous. In the end, both spirals will be reshaped into one vast elliptical system, forever altering the night sky. This is the fate of our home. Not stillness, but transformation. Within the Milky Way itself lie secrets older than the galaxy. Some stars orbiting high in the halo, the outer shell that surrounds the disk, contain almost no heavy elements. These metal poor stars, as astronomers call them, predate the Milky Way itself. Their light tells us they were born in smaller proto-galaxies that merged together billions of years ago. They are survivors of a cosmic dark age, witnesses to the time just after the Big Bang, when the first elements beyond hydrogen and helium were barely beginning to form. Their orbits cut steep angles across the galaxy, a reminder that not everything here was born in one place. The Milky Way is a mosaic of the ancient and the new. Our solar system is one small passenger in this colossal structure. We orbit the galactic center at more than 828,000 kilometers per hour, 230 kilometers every single second. And yet, it takes over 225 million years to complete a single orbit. This is called a galactic year. Since Earth was born, our solar system has only circled the galaxy about 20 times. When the first dinosaurs roamed the Earth, we were in a completely different part of the Milky Way. This means the stars you see above your head tonight are not eternal neighbors. They are temporary companions in a journey that never ends. Everything is in motion. The Earth spins, the Moon circles, the Sun sweeps forward, and the galaxy itself drifts through the expanding fabric of the universe. Even now, material continues to fall into the Milky Way. Gas clouds from the intergalactic medium slip silently into the disk, while small dwarf galaxies are caught, stretched, and consumed. Like a city that grows by absorbing its neighbors, the Milky Way is not finished. It is still expanding, stitched together from countless mergers and collisions. And yet, despite centuries of study, we do not even know something as fundamental as how many arms the Milky Way truly has. From Earth, we are trapped inside its crowded streets, unable to rise above for a clear aerial view. Dust clouds obscure vast regions, and stars blend together into a shimmering fog. Some scientists claim the Milky Way has 4 primary spiral arms. Others argue for 2, with branches and fragments twisting unpredictably. What seems at first like an elegant pinwheel may instead be a chaotic swirl, sculpted by forces we still cannot fully explain. But one truth is clear: the Milky Way is not passive. It is alive with motion, tension, and hidden power. Some of its stars have been flung outward at speeds exceeding 1 million kilometers per hour, fast enough to escape the galaxy entirely. These hypervelocity stars are usually born in pairs near the supermassive black hole at the center. When one star is devoured, the other is catapulted outward, condemned to wander alone in the silent dark between galaxies. They are rare, but they remind us of the violent machinery operating at the core of our home. This is not a fairy tale of distant starlight. It is a story of survival, destruction, and inevitability. Our galaxy is a predator and a prey, a creator and a destroyer, a structure both fragile and unstoppable. The Milky Way is not eternal. It is evolving, colliding, and remaking itself in slow but unrelenting cycles. And as you listen, you are not outside of it. You are inside, moving, orbiting, and destined to take part in its future. The Milky Way's timeline is not simply measured in billions of years. It is etched in the light of stars, in the scars of collisions, and in the quiet chemistry of ancient suns. Imagine this galaxy as a vast archive where every orbit, every burst of starlight, every collapse into darkness becomes a record of what has come before. Tonight, we continue decoding those records. Some stars here are older than the spiral itself. Before the Milky Way had a disk, before it had graceful arms, there were lone stars drifting through the young universe. We know them now as halo stars, ancient wanderers moving in tilted, elongated paths around the galactic core. Their chemical fingerprints show almost no heavy elements, only the primordial hydrogen and helium forged in the Big Bang. They are like cosmic elders, keeping silent testimony of an age before galaxies matured. The fact that these relics still shine tells us that parts of the universe endure even as structures evolve, merge, and vanish. As we orbit within this structure, our solar system traces an immense path around the center. Astronomers call this a galactic year, roughly 225 to 250 million Earth years. In that time, continents split apart, climate shift, and entire species rise and fall. When Earth was covered in swamps and giant insects, the solar system was in a completely different corridor of the Milky Way. Today, we are somewhere new again, drifting along the Orion Spur, a quiet minor lane between major galactic arms. And in the deep future, we will be elsewhere still, witnesses to different stars, different neighbors, a different sky. But while the galaxy holds this slow rhythm, it also pulses with violence. Deep at its heart lies Sagittarius A star, a supermassive black hole more than 4 million times the mass of our Sun. Though invisible, its presence is undeniable. Astronomers have tracked stars whipping around it at extreme speeds, completing orbits in mere years. This hidden monster binds the galaxy together, a silent conductor keeping the stellar orchestra in motion. Sometimes matter falls into it, gas, dust, even stars, and flares of radiation light up the darkness. Scientists suspect that in the past, this black hole was not so quiet. It may once have burned like a quasar, flooding the galaxy with fierce radiation. If true, then the Milky Way's heart once blazed brighter than anything we see in the sky today. And this hidden energy is not confined to the core. Astronomers have discovered vast bubbles of gamma radiation stretching tens of thousands of light years above and below the galactic center. Known as the Fermi bubbles, they glow faintly in wavelengths invisible to our eyes but unmistakable to detectors. Their origin is still debated. Perhaps the black hole's ancient outburst, perhaps colossal bursts of star formation. Whatever their cause, they are proof that our galaxy is not dormant. It breathes, it erupts, it remembers. Beyond the bright disk lies the halo, a spherical shroud surrounding everything we know. Though dim, it contains ancient star clusters, remnants of long-lost galaxies, and oceans of dark matter. This invisible substance outweighs everything we can see, yet we cannot touch it, cannot capture it, cannot even define it. Without dark matter, the Milky Way would fly apart, the stars in its outer arms moving far too fast to remain bound. Instead, they are tethered by an unseen hand. It is the galaxy's hidden skeleton, the framework that allows everything else to exist. Scientists across the globe spend lifetimes trying to decode it, building detectors deep underground, launching satellites into space, searching for even a trace. For now, it remains the most profound, unsolved mystery in modern physics. Meanwhile, within the disk, the spiral arms continue their quiet construction. But these arms are not solid. They are not carved lanes of permanent stars. Instead, they are patterns, density waves moving slowly through the disk, gathering material as they pass. Imagine a cosmic traffic jam. Stars and gas slow, compress, and ignite into new suns. Over time, they drift away, replaced by others. This is why the arms glow, because they are constantly being renewed by stellar nurseries, clouds of gas collapsing into brilliant light. Our own sun was born in such a place, billions of years ago. Somewhere, its siblings still orbit the galaxy, lost to us but still shining in the distance. Even now, clusters of newborn stars form in massive hydrogen clouds. Some are so dense and vast they blot out the starlight behind them, appearing as dark rifts in the night sky. Inside these cold cradles, gravity pulls gas together until nuclear fusion begins. A star is born. Ultraviolet light from these young suns burns away the surrounding clouds, illuminating entire regions with radiant blues and silvers. This constant cycle, birth, life, death, has been the heartbeat of the galaxy for eons. Yet the pace is slowing. Billions of years ago, the Milky Way was a furnace, bursting with new stars. Today, the fires are dimmer. There is still raw material, but it is thinner, more diffuse, harder to ignite. The galaxy has entered middle age, forming stars more slowly than before. This does not mean it is dying, only that it is evolving, entering a quieter phase. Like an empire that has expanded and now consolidates its power, the Milky Way glows, not with youth, but with the measured rhythm of maturity. But maturity does not mean stability. From the outside, our galaxy appears warped, bent like a great spinning sheet caught in a cosmic breeze. Radio telescopes mapping hydrogen gas revealed this distortion. One side of the disk tilting upward, the other downward. The cause? Possibly the gravitational tug of satellite galaxies. Possibly clumps of dark matter beneath the disk. Either way, the Milky Way is not flat. It ripples, it flexes, it dances in response to forces we cannot yet see. And we, tiny passengers orbiting a yellow star on the edge of a minor spur, are part of that dance. Every breath we take, every orbit we complete, is tied to the unseen machinery of a galaxy in motion. We are not separate from it. We are its outcome. From Earth, the Milky Way appears as a delicate streak across the night sky, a luminous band of stars stretching from horizon to horizon. To the naked eye, it looks infinite, overwhelming, and yet what you see is only the faintest fraction of the whole. In fact, under the clearest skies, the human eye can perceive perhaps 6,000 stars. That's 0.0003% of what truly exists in our galaxy. Astronomers estimate more than 100 billion stars orbit within this spiral, and perhaps as many as 400 billion. We live surrounded by an ocean of light, and yet we glimpse only its smallest ripples. But the Milky Way is more than just stars. It is a system of complex layers and shifting structures. At its heart lies a bulge, yet it is not a perfect sphere. It is strangely peanut-shaped, an hourglass made of stars, formed as the central bar buckled upward over billions of years. Gravity sculpts this strange geometry, shaping a galactic heart that defies simplicity. Around this bulge lies the thin disk where we reside, crowded with young stars and fresh star-forming gas. Above and below it, the thick disk drifts, older, puffier, more diffuse, home to stars formed under conditions we can only imagine. The Milky Way is not uniform. It is layered like sediment at the bottom of a cosmic ocean, each stratum preserving a different chapter of galactic history. This history is written not just in shape, but in chemistry. Every star carries a fingerprint, its elemental composition. By analyzing this light, astronomers uncover when and where a star was born. Some stars are rich in heavy metals, forged in regions already seeded by generations of supernova. Others, nearly pure hydrogen and helium, are primordial survivors. This chemical archaeology allows us to reconstruct mergers and collisions, to separate native stars from foreign arrivals, to trace the galaxy's past like detectives piecing together an ancient crime scene. And the evidence is staggering. By following stellar chemistry in motion, scientists have discovered remnants of entire galaxies absorbed by the Milky Way. One of the most significant was the Gaia Enceladus merger, a colossal event billions of years ago that reshaped the galaxy's structure. Its stars still move through our halo, ghostly immigrants pulled apart and absorbed. Similar stellar streams now lace the sky, long ribbons of stars smeared across the disk like trails of spilled light. Each is a fossil of a smaller galaxy that ventured too close, torn apart by tidal forces and woven into the Milky Way's fabric. This process continues even now. Astronomers have mapped dozens of stellar streams, many belonging to faint dwarf galaxies slowly unraveling as we speak. The large and small Magellanic Clouds, bright companions visible from the southern hemisphere, trail vast ribbons of gas hundreds of thousands of light years long. These streams, invisible to human eyes but revealed in radio waves, whisper of an ongoing meal. The Milky Way is still feeding, still reshaping itself, still rewriting its form. Yet for all this motion and violence, the galaxy holds together with a balance that defies our expectations. According to Newton's laws, stars farther from the center should orbit more slowly, just as planets in our solar system do. But in the Milky Way, they don't. Stars on the outskirts move nearly as fast as those near the core. This flat rotation curve was the first great clue to dark matter's existence. Without something unseen providing extra gravity, the galaxy should fling itself apart. Instead, it turns like a solid wheel, bound together by an invisible skeleton. But dark matter is not the only invisible presence. The Milky Way also thrums with magnetism. A vast galactic magnetic field threads through its disk and halo, influencing the motion of cosmic rays, aligning dust grains, and shaping how gas collapses into stars. Though weak compared to Earth's magnetic field, over thousands of light years, it exerts a quiet but profound influence. We cannot see it, but we can measure its effects in the polarized light of distant stars, in the arcs and filaments of gas that bend mysteriously across the sky. This magnetism is part of the galaxy's hidden anatomy, an unseen pulse running through its bones. And within this vast framework, stars themselves live short, dramatic lives. The most massive burn brightly but briefly, dying in titanic explosions known as supernovae. In these moments, the galaxy is both destroyed and enriched. Shock waves ripple through surrounding gas, compressing it and triggering new waves of star birth. Heavy elements like iron, calcium, and gold are forged and scattered into the interstellar medium, seeding future stars and planets with the ingredients of life. Every atom in your body, iron in your blood, calcium in your bones, oxygen in your lungs, was born in such a fire. You are not separate from this cycle. You are a continuation of it. Even death in the galaxy takes many forms. When stars like our Sun run out of fuel, they swell into red giants before shedding their outer layers, leaving behind faint planetary nebulae that drift outward like glowing smoke. At the center, a white dwarf remains, slowly cooling for billions of years. In denser environments, stars may collapse into neutron stars or black holes, extreme objects that warp space and time itself. Some neutron stars, left spinning rapidly, become pulsars, cosmic lighthouses emitting beams of radiation with clock-like precision. Across the Milky Way, hundreds of these silent beacons tick away, marking time on scales far beyond human lifespans. This is the true Milky Way, not a static backdrop for human dreams, but a restless, layered, evolving engine. A city of stars built on ruins, a machine of creation fueled by destruction, a spiral held together by forces we cannot see. And though it feels eternal from our perspective, it is as temporary as any empire. Galaxies rise, change, and fade. The Milky Way will be no different. The deeper we look into the Milky Way, the clearer it becomes. This galaxy is not simply a home. It is a battlefield, a crucible, and a memory bank of cosmic history. Its very structure, its arms, its streams, its warps, are scars of encounters that shaped what we see today. Consider the stellar streams once again. Thin, ghost-like ribbons stretched across the sky. They are fragile but undeniable evidence of conquest. These remnants of destroyed dwarf galaxies wind through the halo like veins, invisible until mapped with precise instruments such as ESA's Gaia spacecraft. Gaia, launched in 2013, has charted the motion of more than 2 billion stars, revealing an astonishing truth. The Milky Way is stitched together from dozens of smaller galaxies, each absorbed into the whole. Every stream is a story of destruction. Every orbiting star is a survivor of assimilation. In this sense, the Milky Way is less a single galaxy and more a coalition built through relentless gravitational politics. And the wars are not over. The Magellanic Clouds, two luminous companions in the southern sky, may only recently have fallen under our galaxy's sway. Their arrival has stirred the Milky Way's outer disk, warping its shape like a sheet tugged at the edges. They trail behind them the Magellanic Stream, a colossal ribbon of hydrogen gas that stretches over 600,000 light-years, far beyond the visible boundaries of the galaxy. This is a sign not just of past struggle, but of future growth. That gas may one day rain back into the disk, fueling new star formation, prolonging the galaxy's life. But even as material flows in, some stars are cast out. In the dense heart of the Milky Way, near the supermassive black hole, binary stars can be ripped apart. One star is swallowed whole. The other is flung outward at impossible speeds, exceeding 500,000 kilometers per second. These hypervelocity stars are exiles, condemned to drift through intergalactic space, forever cut off from the galaxy of their birth. They are living proof that even in the realm of gravity, there are moments of escape, violent expulsions that punctuate the steady rhythm of orbits. This rhythm is far from simple. Unlike planets orbiting the Sun, stars in the Milky Way do not follow neat, predictable paths. Instead, they move with chaotic freedom. Those closer to the center orbit faster. Those farther out drift more slowly. This uneven dance is what creates spiral arms, not fixed structures, but patterns born of density waves, like traffic jams that ripple through the galaxy. Stars move in, linger, and move out again, while gas clouds ignite into new generations of stars. It is a dance of delay, compression, and release. And we are part of it. Our Sun is just one dancer in this immense current, carried along by the wave. But not all stars follow the rules. Some orbit backward, against the main direction of galactic rotation. These retrograde stars are relics of captured galaxies, their motions frozen reminders that they were not born here. Like dissenting voices in a chorus, they cut across the rhythm, revealing layers of history invisible to the naked eye. Their very existence confirms that the Milky Way is a product of mergers, each collision leaving behind not just light, but motion, a quiet signature of foreign origin. The galaxy itself is not symmetrical either. For centuries, we imagined the Milky Way as a perfect pinwheel, a balanced spiral turning serenely in space. But modern observations show otherwise. The disk is lopsided. One side is thicker, some arms brighter, others bent or truncated. Even the stellar halo is slightly off-center. These irregularities may be caused by gravitational encounters with smaller galaxies or dark matter clumps lurking unseen. They remind us that order in the cosmos is often an illusion. The Milky Way is not perfect. It is scarred, bent, and asymmetrical, shaped by time and conflict. And yet, there is beauty in this imperfection. Stellar nurseries, vast clouds of hydrogen and dust, ignite along the spiral arms, giving birth to new stars that burn brilliant and short. Supernovae explode like cosmic storms, scattering heavy elements across the interstellar medium. These elements, iron, oxygen, carbon, become the building blocks of new planets, oceans, and life itself. The galaxy recycles endlessly. Stars die, their ashes seed the birth of new generations. Every atom in our bodies is part of this grand circulation. You are not outside of it. You are a direct descendant of ancient stars. But the cycle is slowing. Astronomers believe the Milky Way's rate of star formation peaked billions of years ago. Today, the fires burn less intensely. It is still forming stars, but not with the ferocity of its youth. This does not mean the end. Rather, it is a sign of maturity. The Milky Way is in its middle age, glowing steadily but no longer frantic, a galaxy past its most explosive phase. And yet, time is not on its side. Galaxies evolve, they merge, they fade. The Andromeda Galaxy drifts closer each day, destined to collide and transform everything. The Milky Way, as we know it now, is temporary. Its beauty lies not in permanence, but in change. The Milky Way is not simply an object of wonder. It is a system in constant flux, driven by hidden forces that defy human intuition. Its apparent stillness in the night sky is an illusion. Beneath the calm band of starlight lies a restless engine where destruction and renewal proceed side by side. Begin with the disk itself. We tend to imagine it as a smooth, flat spiral, but in truth, it bends, warps, and even wobbles like a plate set spinning unevenly. Radio telescopes mapping hydrogen gas have revealed subtle ripples across the galactic plane. These distortions are not random. They may be caused by the gravitational tug of satellite galaxies, by infalling gas streams, or by concentrations of dark matter hidden in the halo. The galaxy is not still. It flexes like a living organism responding to unseen pressure. From afar, it would look as if the Milky Way were breathing, bending one side upward, the other downward, in a slow-motion dance measured over millions of years. Surrounding this disk is the halo, a vast sphere of near-invisible matter. Within it drift over 150 globular clusters, dense spheres of hundreds of thousands of ancient stars, some more than 12 billion years old. These clusters are survivors of the earliest cosmic epochs, long before the Milky Way as we know it had formed. Their stars are poor in heavy elements, proof that they were born before the universe had time to forge much beyond hydrogen and helium. They are fossils in orbit, glowing time capsules that tell us what conditions were like when galaxies were only just beginning to take shape. But the halo's most mysterious occupant is not visible at all. It is dark matter, a form of mass we cannot see, touch, or produce in laboratories. And yet, it outweighs all visible stars, gas, and dust many times over. Without it, the outer stars of the Milky Way would spin free into intergalactic space. With it, the galaxy holds together, its spiral arms locked into place by an invisible skeleton. We do not know what dark matter is. It could be exotic particles, primordial black holes, or something beyond physics as we know it. But we do know that without it, galaxies could not exist. Dark matter is the silent architect of structure in the universe. This architecture is not symmetrical. Recent surveys show that the Milky Way is lopsided. Thicker on one side, its halo uneven, its spiral arms longer and brighter in some directions. These imbalances are not flaws. They are fingerprints of history. They are signs of collisions, mergers, and encounters with dwarf galaxies. Just as empires in human history carry the marks of wars, treaties, and annexations, the Milky Way bears the scars of its cosmic diplomacy. Its asymmetry is proof that galaxies do not grow in isolation. They evolve in a contested environment, shaped by both allies and enemies. Inside the disk, vast clouds of molecular hydrogen serve as the wombs of future stars. Some are so cold and dense they block visible light entirely, appearing as black patches across the starlit sky. Within these hidden cradles, gravity slowly compresses material until fusion ignites. New stars flare into existence, surrounded by rotating disks of dust that may one day form planetary systems. Even our own sun was born in such a cradle, most likely alongside hundreds of siblings that have since scattered across the galaxy. The family of our star is still out there, lost but not gone. Yet not every cloud produces stars. Some remain dark, stabilized by turbulence or magnetic fields, drifting silently through the galaxy. They are reservoirs of potential, waiting for the right trigger, perhaps a shockwave from a supernova, to collapse and ignite. In this sense, the Milky Way is a galaxy of deferred possibilities, carrying within it regions of material that may never fully awaken. And when stars do die, they do not vanish quietly. Supernovae act like storms in the galactic ecosystem. They tear apart their parent stars, but they also seed the interstellar medium with heavy elements and energy. Shockwaves ripple outward, compressing nearby gas and igniting the next cycle of star formation. It is destruction that fuels creation, a violent renewal that ensures the galaxy does not stagnate. Without supernovae, there would be no Earth, no oceans, no iron, no life. The galaxy, then, is not static. It recycles. Matter passes through generations of stars, scattered by death, reassembled by gravity, and reignited into new light. Every atom in your body has undergone this cycle, born in ancient stars, expelled into space, gathered into new clouds, and eventually folded into Earth. You are, quite literally, the galaxy made conscious. But even this recycling has its limits. The rate of star formation is slowing. Billions of years ago, the Milky Way burned brighter, producing new stars at a furious pace. Now, the reservoir of cold gas is thinning. Much remains, but it is harder to compress, harder to ignite. The galaxy is entering a quieter phase, no longer a fiery young empire, but a mature state, glowing steadily in middle age. It is still alive, but no longer in a hurry. Yet its future is not decline, it is transformation. In billions of years, Andromeda will arrive. The Milky Way will not fade away quietly. It will merge, absorb, and reconfigure into something new. Even now, faint whispers of that destiny are written across the night sky. When we look at the Milky Way with modern instruments, we see not a static spiral, but a dynamic arena of conflict and change. Like human civilizations, galaxies rise, consolidate power, absorb rivals, and eventually fall into new orders. The Milky Way is no exception. It has fought wars of assimilation, carved out spheres of influence, and even now prepares for its most consequential merger with Andromeda. In its structure, we see echoes of our own history, a reminder that survival, whether for nations or galaxies, depends on adaptation. The galaxy's disk is a busy thoroughfare filled with stars of different ages moving at different speeds. Unlike the orderly orbits of planets around the Sun, stars follow complex paths, racing ahead in the inner regions while drifting slowly on the outskirts. This uneven motion gives rise to spiral arms, density waves that compress gas and ignite new generations of stars. These arms are not permanent, but shifting patterns, always dissolving and reforming. To imagine them as fixed is to miss their true nature. They are currents in a cosmic ocean. Our own solar system drifts in and out of these arms, spending millions of years in brighter neighborhoods before returning to quieter lanes like the Orion Spur, where we now reside. And yet, even in this quiet region, the galaxy's violence is never far. Hypervelocity stars, rare, extraordinary fugitives, slice through space at speeds exceeding 1 million kilometers per hour. Many are born in binary systems near the supermassive black hole. One partner is devoured, the other flung outward like shrapnel. These exiled suns remind us that stability is temporary. Even in a system bound by gravity, there are violent expulsions, acts of separation that scatter stars beyond the galaxy's edge. Closer to the galactic core, the story grows more extreme. Sagittarius A star, the black hole anchoring the Milky Way, is a silent giant today. But evidence suggests it was once far more active. Astronomers studying gamma-ray structures above and below the disk, the enormous Fermi bubbles, believe they may be remnants of an outburst when the black hole devoured vast quantities of gas. If so, then the Milky Way once blazed with quasar-like intensity, flooding space with radiation that would have altered the environment of countless stars. It is a chilling reminder, even dormant giants can awaken. And not all the galaxy's turbulence is centered in its heart. The interstellar medium, the thin soup of gas, dust, and plasma between stars, is a restless sea. Supernova shockwaves carve bubbles in cavities. Stellar winds sculpt filaments that stretch for light years. Magnetic fields twist this material into loops and arcs. This hidden fabric, invisible to human eyes, is the true engine of galactic evolution. It governs star formation, recycles matter, and even regulates how energy flows from the disk into the halo. To call it empty space is a mistake. It is the galaxy's bloodstream. Above and below the disk, chimneys of hot gas vent into the halo, powered by clusters of supernovae. These superbubbles regulate pressure and spread heavy elements far from their origins. They are the Milky Way's exhalations, giant breaths that connect its inner workings with its outer halo. Meanwhile, inflows of cold gas from the cosmic web replenish what is lost, ensuring the cycle continues. The galaxy does not live in isolation. It is linked to the universe beyond, drawing sustenance from invisible filaments that stretch across intergalactic space. And woven through all of this is the mystery of cosmic rays. These high-energy particles, accelerated by supernovae and black holes, stream across the galaxy and pass through our bodies every second. We cannot see them, but their presence is constant, a reminder that the galaxy hums in frequencies beyond human senses. Neutrinos, ghostly particles produced in nuclear reactions, slip through entire planets as if they were not there. They are whispers from the cores of stars, evidence of processes we cannot otherwise observe. Even as you stand on Earth, you are being touched by streams of energy that began in distant corners of the Milky Way. The scale of this hidden world is staggering. Every second, billions of particles from our galaxy move through you. Every night, when you look at the Milky Way, you are seeing not just light, but history. Light that began its journey thousands, millions, even billions of years ago. Some of the stars you see may already be gone, their light only now arriving. Others will outlive our civilization by trillions of years. In the Milky Way, time is not linear. It is layered, stretched, and folded into every star, every orbit, every trail of gas. And yet, for all its power and complexity, the Milky Way is fragile in its own way. Its survival depends on balance, the inflow of gas against the loss of matter, the gravity of dark matter against the outward pull of rapid rotation. If either side falters, the structure would unravel. It is the same for human empires. Expansion and collapse are two sides of the same process. The Milky Way is both stable and temporary, both ancient and impermanent. We are not observers of this story, we are participants. Our solar system is one cell in this vast body, one orbit in its colossal dance. To study the Milky Way is not simply to look outward. It is to look inward, to recognize that our history, our very existence, is inseparable from the life cycle of this galaxy. When we speak of the Milky Way, we speak not only of a galaxy, but of an empire of stars, expansive, layered, and restless. Like human empires that rise through conquest and decline through excess, the Milky Way expands through mergers, sustains itself through recycling, and prepares, without knowing, for its eventual collapse into something new. It is a system bound by invisible laws, its destiny written not in politics or ideology, but in gravity. The Milky Way's arms are its highways, lanes of density where gas and stars gather. Yet these arms are not permanent roads. They are patterns, density waves rolling through the galactic disk. As they pass, they compress gas clouds, triggering bursts of star formation. New stars flare into life, shine for millions or billions of years, and then drift out of the wave, replaced by the next generation. To see the spiral arms glowing in photographs is to see a wave frozen in time, a structure that only exists because it is constantly renewed. Our own sun is one of these travelers, passing in and out of arms as it completes its orbit around the galactic core. In each passage, the neighborhood of the solar system changes. Our sky is never permanent. But the arms are not safe. They are crowded, chaotic regions where supernovae erupt more frequently, flooding space with radiation. Some scientists even speculate that Earth's history of mass extinctions may correlate with our solar system's path through spiral arms. In these crowded districts of the galaxy, death comes more often. And so, ironically, life may owe its survival to the Orion Spur, the quiet backstreet between major arms where the solar system now drifts. Our position may be an accident, but it is an accident that gave Earth the stability needed for life to evolve. Still, danger lurks everywhere. Rogue planets, worlds untethered to any star, drift silently through the galaxy. Some formed around stars and were ejected by violent gravitational encounters. Others may never have had a parent star at all. They are cold, lightless, invisible to the human eye. And there may be billions of them, dark wanderers in the halo and beyond. If one were to pass through our solar system, the consequences could be catastrophic. Yet for now, they remain unseen, a reminder of how much we still do not know. Above and below the galactic disk, vast bubbles of hot gas rise like chimneys, venting the energy of clustered supernovae. These structures carry enriched material into the halo, where it eventually cools and rains back down in a galactic fountain. In this way, the Milky Way breathes, exhaling gas through violent outbursts, inhaling it again through quiet inflows. It is not static, but circulatory, alive with the rhythms of renewal. And those inflows do not only come from within. The galaxy is connected to the larger universe through the cosmic web, invisible filaments of gas and dark matter stretching across millions of light years. Streams of cold gas flow along these filaments into the Milky Way, feeding it like arteries from a greater body. Without this supply, the galaxy would starve. With it, it continues to grow, not as a living being, but as a gravitational structure deepening over time. This connection means the Milky Way is not an isolated empire. It is part of a network, a cluster of neighbors called the local group, bound together in a slow-motion ballet. In this group, the Milky Way and Andromeda are the superpowers, each with satellite states in the form of dwarf galaxies. Between them lies empty space, but also inevitable destiny. Gravity is already deciding the outcome. In 4.5 billion years, the two will merge, reshaping the balance of the local group entirely. It will be a geopolitical realignment on a cosmic scale, where the map of galaxies is redrawn not by treaties or wars, but by the unyielding force of attraction. Yet even now, smaller galaxies orbit like vassal states around the Milky Way. Some, like the Sagittarius dwarf, are being dismantled in real time. Others, like the Magellanic Clouds, still resist, trailing long streams of gas but not yet fully consumed. These companions are both resources and threats, sources of material that will enrich the Milky Way, but also agents of disruption that warp its disk and destabilize its symmetry. The relationship between a great power and its satellites is never simple, whether in human history or in galactic evolution. And deep in the halo, beyond the luminous disk, stars orbit in elongated, tilted paths, evidence of mergers long past. Their motions are clues, like ancient inscriptions carved into stone. By tracing them, astronomers reconstruct the Milky Way's chaotic history, revealing that our galaxy is not a singular creation, but a mosaic assembled from fragments of others. Every merger left scars, every encounter left signatures, every absorbed galaxy left children now indistinguishable from our own. The Milky Way, like all empires, is built from the ruins of what came before. This is the truth hidden in the night sky. What appears eternal is in fact transient. What seems stable is always in motion, and we, fragile and temporary, are swept along in that current. The Milky Way is not just our home, it is our history, our present, and our future. The Milky Way, for all its brilliance, is not invincible. Like every empire, it shows signs of strain, asymmetry, and a destiny beyond its control. The galaxy is not a permanent structure frozen in the void. It is a system in transition, evolving through cycles of creation and collapse. Its fate, like that of nations and civilizations on Earth, is already sealed by forces larger than itself. Look first at its uneven balance. The galaxy's mass is not distributed evenly. One side of the disk appears thicker, its arms more pronounced. The stellar halo is offset, stretched in odd directions. These irregularities are scars of collisions, the gravitational aftermath of absorbing smaller galaxies. Astronomers compare the process to a city growing chaotically, adding new districts from conquered neighbors, leaving a patchwork that is vibrant but imperfect. Perfection is a myth. The Milky Way's strength comes not from symmetry, but from survival, from its ability to endure upheaval and continue expanding. But the price of survival is instability. As the Milky Way consumes, it is also warped and reshaped. Its disk wobbles as it spins, tilted like a great wheel out of balance. Stellar streams wrap around it like ghostly rivers, the remains of former companions. To study these structures is to read the Milky Way's secret history, not a story of harmony, but of struggle. It is a reminder that power, whether in galactic or human terms, is never achieved without disruption. Deep within the disk, vast clouds of dust obscure whole regions of star formation. To human eyes, they appear as voids, patches of darkness blotting out the stars. But infrared telescopes reveal the truth. Behind these veils lie stellar nurseries, glowing cradles where new suns are being born. What looks like emptiness is often abundance. The Milky Way hides its greatest activity in shrouds of dust, concealing both creation and chaos. And yet, even these cradles face limits. The galaxy is running out of the dense, cold gas needed to make stars. Billions of years ago, it burned like a furnace, producing stars at a furious pace. Today, that pace has slowed dramatically. Star formation continues, but at a declining rate. The Milky Way is not dying, it is settling into middle age. But the long-term trajectory is clear. The golden age of stellar birth is over. This galaxy is no longer an expanding empire of youth. It is a mature power, conserving resources, preparing, unwittingly, for merger. That merger is not a possibility, it is inevitable. Andromeda is on approach, closing the distance every second. In 4 to 5 billion years, the two superpowers of the local group will collide. Unlike the smaller galaxies the Milky Way has absorbed, Andromeda is nearly equal in size and mass. The collision will not be a swift conquest, but a slow, elegant war of gravity lasting billions of years. Stars will be thrown into new orbits. Spiral arms will unravel into long tidal tails. Central black holes may spiral together, fusing into an even greater singularity. The result will not be a spiral at all, but a vast elliptical galaxy, an empire transformed beyond recognition. And as always, the human story is tied to this cosmic arc. If life still endures when the merger begins, descendants of Earth may look up at a night sky ablaze with two galaxies colliding. For them, it will not be a distant theory, but a lived reality, a spectacle of transformation that dwarfs every event in human history. The Milky Way, our home for billions of years, will cease to exist as we know it. In its place will rise something new, stitched from the ruins of two giants. This is the destiny of galaxies: to consume, to be consumed, and to be remade. In this way, the Milky Way mirrors the cycles of empires, nations, and civilizations on Earth. No power endures unchanged. Growth brings instability, conquest brings scars, and in time, every structure is reshaped by forces larger than itself. The Milky Way is no exception. It is vast, ancient, and radiant, but it is not eternal. And yet, within that impermanence lies meaning. The atoms in your body, the oxygen you breathe, the iron in your blood, the calcium in your bones, were forged in stars that lived and died billions of years ago. You are not outside this cycle. You are part of it. You are the Milky Way made conscious, a fragment of the galaxy reflecting on its own history. The Milky Way is not only a system of stars and gas, it is a factory of cycles, a machine of birth, death, and transformation. At the smallest scale of individual stars, and at the largest scale of galactic mergers, the process is the same: creation through destruction, renewal through collapse. This is the heartbeat of our galaxy. Every star follows a path dictated by its mass. The smallest stars, red dwarfs, burn slowly and quietly. Some will live for trillions of years, longer than the universe has even existed so far. These dim suns may outlast everything we know, flickering long after brighter stars have vanished. But the most massive stars live fast and die violently. They burn through their fuel in only millions of years before collapsing in spectacular supernovae. In these brief but furious deaths, the galaxy is enriched with heavy elements: oxygen, iron, carbon, even gold. Without these explosions, there would be no planets, no oceans, no life. Supernovae also send shock waves crashing through surrounding clouds of gas, triggering new waves of starbirth. In this way, the death of one star seeds the lives of many others. It is a chain reaction, a cosmic wildfire that keeps the galaxy alive. Even neutron stars, the collapsed cores left behind, continue to influence their environment. Some spin rapidly, becoming pulsars that sweep beams of radiation across space like cosmic lighthouses. Others merge, producing bursts of gravitational waves that ripple through the very fabric of space-time. These events are rare, but they are transformative, scattering new elements and reshaping the galaxy in subtle ways. Not all remnants are so dramatic. Stars like our Sun will die more quietly. When they run out of fuel, they swell into red giants, shedding their outer layers into glowing planetary nebula. At the center, a white dwarf remains, a dense ember the size of Earth, slowly cooling over billions of years. Though faint, these remnants are everywhere, hidden among the stars. They are silent testimonies that even stars, like civilizations, eventually exhaust their resources and fade. But the Milky Way's recycling system goes beyond individual stars. Gas flows across vast distances, shaped by winds, radiation, and gravity. When clusters of stars form, their combined light carves cavities into the surrounding medium, creating enormous bubbles of hot ionized gas. These superbubbles can expand for hundreds of light years, colliding with each other, venting into the halo, and returning in galactic fountains. Through this process, elements forged in stellar cores are mixed into the wider galaxy, ready to form new stars, new planets, and perhaps new life. The galaxy also pulses with invisible energy. Cosmic rays, charged particles accelerated by supernovae and black holes, race across the Milky Way at nearly the speed of light. Every second, thousands of them pass through your body. Neutrinos, ghost-like particles born in nuclear reactions, flow through entire planets without slowing. They are messengers from the heart of stars, whispers of processes hidden from direct view. And gravitational waves, ripples in space-time itself, wash across the galaxy when massive objects collide. These waves are faint, but they carry stories of cataclysms so violent they reshape the universe. Together, these unseen forces form a hidden web of influence, linking every part of the Milky Way. What we see as light is only a fraction of the story. Beneath the visible lies a world of radiation, particles, and waves that never stop moving. They are the bloodstream and nervous system of the galaxy, constant, invisible, and essential. Yet, for all its cycles of renewal, the Milky Way is finite. Its star formation is slowing, its fuel is dwindling. Over cosmic timescales, it will grow quieter. Billions of years from now, the galaxy will produce fewer and fewer new stars. White dwarfs will fade into black dwarfs. Neutron stars will cool, and even black holes may evaporate through Hawking radiation. The Milky Way's bright spiral will dim, its cycles will stall, and eventually it will merge into something larger, losing its identity in the process. This is the paradox of the galaxy. It is both creative and destructive, both ancient and temporary. Its beauty lies in impermanence. To study the Milky Way is to understand that nothing lasts forever. Not stars, not galaxies, not even the universe itself. But it is also to realize that in this endless cycle, new forms always emerge. From the ashes of stars came Earth. From the dust of explosions came life. From the chaos of mergers came the Milky Way itself. You are living proof that destruction breeds creation. The atoms in your body have been recycled through stars, gas, and explosions countless times. In you, the galaxy is reflecting on itself. You are not separate from this cycle. You are its continuation. The Milky Way, like every galaxy, is not a permanent monument. It is a stage in a larger story, a story written across billions of years and billions of light years. To understand its future, we must step back, beyond its spiral arms, beyond its halo, into the wider context of the local group and the expanding universe itself. The local group is our immediate neighborhood in the cosmos, a gravitationally bound collection of more than 80 galaxies. At its center are two giants, the Milky Way and the Andromeda Galaxy. Together, they dominate, each surrounded by satellite dwarfs, smaller companions that orbit like vassal states. The Magellanic Clouds circle us. M32 and M110 accompany Andromeda. Beyond them lie dozens of faint dwarfs, many of them so diffuse they are invisible without the most powerful telescopes. They are fragile, but they tell us something crucial. Galaxies do not live in isolation. They are part of families, hierarchies, and networks. And in this family, a great event looms. Andromeda is not drifting away, it is falling toward us. Though the universe as a whole expands, local gravity dominates here. The two great spirals are on a collision course, closing the distance at about 110 kilometers per second. In 4 to 5 billion years, the impact will begin. But it will not be an instant cataclysm. It will unfold over billions of years, a slow-motion ballet of destruction and renewal. First, their halos will meet, dark matter pressing into dark matter, invisible but decisive. Then their disks will collide, stars flung into new trajectories, gas clouds compressing and igniting bursts of star formation. Spiral arms will unravel, tidal tails will stretch across space like cosmic ribbons. The night sky from Earth, or whatever planet still hosts observers, will be unrecognizable. And eventually, the two central black holes will spiral together, merging in a cataclysm of gravitational waves that will ripple through the fabric of space-time itself. The end result will not be two galaxies at all, but one. Astronomers call it Milky, a giant elliptical galaxy that will dominate the local group. Its spiral elegance will be gone, replaced by a smoother, rounder structure. The Milky Way as we know it will vanish into something larger. Like empires that merge into new states, it will lose its identity in the act of transformation. And yet, this is not death. It is continuity by other means. Beyond the local group lies the Virgo supercluster, and beyond that, the vast cosmic web. But even this structure has a future. Because the universe is expanding, not just expanding, but accelerating. Dark energy, the mysterious force driving this acceleration, ensures that galaxies outside our local group will recede faster and faster until they slip beyond the horizon of visibility. In tens of billions of years, the night sky will grow emptier. The Milky Way, Andromeda, and their satellites will merge into one great island galaxy, floating alone in a darkening universe. This isolation will not be immediate, but it is inevitable. Already, galaxies billions of light-years away are moving faster than light relative to us, not because they are breaking cosmic laws, but because space itself is stretching between us. One day, only our local island will remain visible. For future observers, if any survive, it will seem as if the universe contains only one galaxy. The truth of the wider cosmos will be hidden forever. And beyond that, even larger scales of time await. Stars will continue to form, but more slowly. White dwarfs will cool into black dwarfs. Neutron stars will fade. Black holes will dominate, swallowing what remains. And in unimaginable spans of time, even black holes may evaporate through Hawking radiation, leaving behind only a thin sea of particles in an ever-expanding void. This is the long fate of the Milky Way: collision, merger, transformation, and eventual silence. And yet, within that arc lies meaning. We live in a moment of extraordinary privilege, able to see the galaxy in its spiral form, able to map its neighbors and trace its history and glimpse its future. We exist during a narrow window in cosmic history when the night sky is rich with galaxies, when the universe is still young enough to reveal its secrets. In billions of years, that view will be gone. But today, it is ours. The Milky Way is not eternal. It is transient. But so are we. And in that shared impermanence lies a strange kind of kinship. We are passengers in the galaxy, temporary, fragile, but real. And perhaps that is enough. This is breaking news from the universe itself. The Milky Way, our galactic home, is already on a countdown. Though the collision with Andromeda lies billions of years away, the signs of upheaval are visible now. Astronomers are piecing together evidence of a galaxy in motion, an empire preparing, knowingly or not, for its greatest transformation. Consider the Sagittarius dwarf galaxy. Once independent, now it is being consumed. Its stars, stretched into elongated streams, wrap around the Milky Way like luminous scars. These stellar rivers are not accidents. They are crime scenes, evidence of a cannibalistic act in progress. Scientists tracking them describe the Milky Way as a predator, devouring smaller galaxies to strengthen itself. It is a conquest written not in borders, but in gravitational tides. Next comes the Magellanic Clouds, two companions visible in the southern hemisphere. For centuries, they seemed stable, loyal satellites. But radio telescopes reveal the truth. They are unraveling. Behind them trails the Magellanic Stream, a ribbon of hydrogen gas nearly 600,000 light-years long. This is not loyalty. It is surrender. The Milky Way is stripping them bare, pulling them into its gravitational grasp. These clouds may resist for now, but the outcome is already decided. They too will fall. Even the structure of the Milky Way itself reveals instability. Its disk is warped, bent like a record left too long in the sun. The cause? Likely the tug of satellite galaxies and the uneven pull of dark matter. The warp is not cosmetic. It is evidence that the galaxy is under stress, distorted by external pressures. Imagine a skyscraper swaying in the wind. The Milky Way is that skyscraper, bending under forces we cannot see but know are there. And at the center, the most chilling figure of all, Sagittarius A star, the supermassive black hole. For now, it sleeps, quiet and restrained. But the past tells a different story. The Fermi bubbles, enormous plumes of gamma radiation above and below the disk, suggest that this black hole once erupted, consuming vast quantities of matter and blasting energy into space. If it happened before, it can happen again. The calm at the core may be temporary. The Milky Way's heart is not dead, it is dormant. This is not just science, it is a forecast. In the future, Andromeda will appear in the night sky as a faint smudge, then as a sprawling rival, and finally as a direct intruder. The two galaxies will clash, their disks colliding, their arms tearing apart, their stars flung into intergalactic exile. Some systems will be cast into darkness, others ignited in bursts of new star formation. Black holes will spiral together, releasing gravitational waves that echo across the cosmos. For billions of years, the Milky Way will not be the galaxy we know. It will be something unrecognizable, caught in the slow violence of transformation. But this is not only the Milky Way's fate, it is the fate of all galaxies. The universe is not static. It is an endless cycle of mergers and dissolutions, of power gained and power lost. Just as empires on Earth expand, fracture, and reform, so too do galaxies. What we call the Milky Way is a temporary name for a temporary structure. In time, it will be swallowed into something larger, its spiral arms erased, its very identity forgotten. And yet, for now, we remain inside it, witnesses, participants, and products of this vast system. The stars above you tonight are not eternal. They are temporary companions in a galaxy that is itself temporary. But while it lasts, the Milky Way is magnificent. And while we exist within it, so are we. Breaking news: the Milky Way is changing before our eyes. Though human lifespans are too short to witness these transformations directly, astronomers have assembled the evidence. When we connect the dots, the story becomes clear. Our galaxy is not a fixed backdrop, but a living system caught in motion. If this were a newsroom, the updates would be flashing every second from across the cosmos. Report 1: Galactic cannibalism confirmed. Astronomers using the Gaia spacecraft have traced stellar streams that once belonged to entire galaxies. The Sagittarius dwarf, Gaia Enceladus, and others have been torn apart and absorbed. Their stars now orbit within the Milky Way, indistinguishable to the naked eye, but carrying chemical fingerprints of foreign origin. This is the equivalent of a geopolitical map being redrawn through quiet annexation. The Milky Way is not a peaceful spiral, it is an empire built on conquest. Report 2: The core is alive. Sagittarius A star, our supermassive black hole, is not as quiet as it seems. Evidence suggests it has erupted before, blasting energy into the galaxy with unimaginable force. Gamma-ray bubbles, tens of thousands of light-years across, still glow above and below the disk. They are the smoking gun of an active past. If the core flared again, the consequences for nearby systems could be catastrophic. What looks calm today may only be the pause between storms. Report 3: The disk is warped. New radio maps reveal that the Milky Way's disk is bent and twisted, as though pulled by unseen hands. This distortion could be caused by the Magellanic Clouds tugging at the galaxy with their gravity, or by massive clumps of dark matter hidden in the halo. Either way, the message is clear: our galaxy is not stable. Its very structure is being reshaped by forces we barely understand. Report 4: The future collision. The Andromeda Galaxy, our cosmic rival, is closing in. Current measurements place the timeline for merger at roughly 4.5 billion years. To human civilization, that sounds eternal. But in galactic terms, it is soon. The collision will not be a single impact, but a drawn-out war of gravity. Stars will be scattered, spiral arms will unravel, black holes will spiral together. In the end, a new galaxy will be born, and the Milky Way will cease to exist as we know it. Report 5: The slow fade. Even without Andromeda, the Milky Way is aging. Star formation is slowing as gas supplies thin. Billions of years ago, the galaxy was a furnace of creation, birthing stars at a furious pace. Now, that pace has dropped. We live in a quieter era, one of maturity rather than expansion. The galaxy is not dead, but it is past its youthful peak. This is not decline, it is transition. But like every empire in history, the Milky Way cannot escape change. Special analysis: what this means for us. We live on a small planet orbiting a modest star, tucked into a quiet spur of a spiral arm. From this vantage point, the galaxy seems eternal, unchanging. But the reality is different. We are passengers on a vessel in motion, part of a system that will transform, merge, and eventually fade. Our very atoms are proof of this cycle. Born in ancient stars, scattered through explosions, reassembled into life. We are the galaxy thinking about itself. Final note: the Milky Way is not a still photograph. It is a breaking story unfolding in real time across billions of years. And right now, we are in the middle of it. The galaxy is not waiting. It is moving, breathing, devouring, and preparing for its future. This is the news from the cosmos. Our home is temporary, magnificent, and destined for change. Breaking news update: the fate of the Milky Way is tied to the fate of the universe itself. To understand our galaxy's destiny, we must widen the scope beyond the local group, beyond the Virgo supercluster, to the cosmic stage on which everything unfolds. The universe is expanding. This discovery, made just over a century ago, changed everything. Distant galaxies are not standing still. They are racing away from us, their light stretched into longer, redder wavelengths. And this expansion is not slowing down. It is accelerating, driven by something we call dark energy, a force that makes up nearly 70% of the cosmos, but remains utterly mysterious. Its influence guarantees one thing: galaxies beyond our local group will continue to recede until they vanish beyond the cosmic horizon, never to be seen again. This has profound consequences for the Milky Way's future. For now, we live in a rich universe, surrounded by galaxies we can observe, study, and learn from. But billions of years from now, when the Milky Way and Andromeda have merged into a single elliptical giant, that richness will fade. The night sky will empty. The cosmic web itself, the vast structure of filaments connecting galaxies, will stretch beyond reach. For future civilizations, the universe will appear smaller, lonelier, and more static than it truly is. They will not see the grand design we see today. They will be isolated, stranded on an island of stars. But even within this shrinking stage, the cycles continue. The new Milky galaxy will contain trillions of stars, many newly born in the chaos of the merger. But star formation will eventually decline as gas supplies run out. The galaxy will grow older, redder, quieter. White dwarfs, neutron stars, and black holes will dominate the population. Supernovae will become rare. Stellar nurseries will close. The cosmic engine will slow. And then, over timescales that defy imagination, the universe enters what physicists call the degenerate era. Stars fade into cold embers. Black dwarfs replace white dwarfs. Neutron stars remain, silent and dense. Black holes prowl, consuming what little matter remains. The galaxy becomes a graveyard of remnants, faint and fading in the dark. Even black holes cannot last forever. Over unimaginable eons, they evaporate through Hawking radiation, releasing energy until they disappear entirely. When that happens, the Milky Way, its stars, its planets, its history, will be gone. The very matter of the galaxy will dissolve into a thin sea of particles scattered across infinite space. This is the heat death of the universe, the final stage of cosmic evolution. No stars, no galaxies, no structures. Only an endless expanse of near absolute zero, where time itself loses meaning. If the Milky Way is an empire, then this is the collapse not only of the empire, but of the entire world it once inhabited. And yet, there is a strange beauty in this inevitability. For in the brief span when the Milky Way shines, when stars burn, when planets orbit, when life emerges, the universe is alive with meaning. We are fortunate to exist in this window, when galaxies can still be seen, when stars still shine, when the cosmos still reveals its secrets. In the long arc of eternity, this is the golden hour. The Milky Way's fate is sealed. It will merge, evolve, fade, and dissolve. But while it lasts, it is magnificent. And within its arms, on a small blue planet orbiting a modest star, consciousness has arisen to witness the story. We are not outsiders looking in. We are the Milky Way, reflecting on itself before the curtain falls. Final broadcast. The Milky Way story reaches its closing act. This is not a tale of permanence. It is a breaking news report from the cosmos, and the headline is clear. Everything changes, even galaxies. The Milky Way, our shining spiral of stars, our home in the void, is temporary. It has devoured others. It will collide with Andromeda, and one day it will vanish into the silence of cosmic time. And yet, in this transience, there is significance. The Milky Way is not just a structure of stars and dust. It is a system that made Earth possible. It forged the atoms of our bodies in stellar furnaces. It sculpted our solar system from collapsing clouds. It gave us the light to see, the oxygen to breathe, and the iron to carry in our blood. To look at the Milky Way is not just to look outward, it is to look inward, into our own origins. Right now, astronomers across the world act as reporters, decoding the signals from across the galaxy. They map stellar streams, the trails of cannibalized galaxies. They measure the spin of stars in the outer disk, revealing the invisible skeleton of dark matter. They study bursts of gamma rays, chart the ripples of gravitational waves, and search for the faint traces of neutrinos whispering from stellar cores. Each discovery is not just data, it is a dispatch from the Milky Way itself, telling us what it was, what it is, and what it will become. But the greatest revelation is this: we are part of the story. The atoms in our cells were born in ancient stars. The cycles of life on Earth are tied to the rhythms of galactic motion. Even our future, billions of years from now, will be shaped by the coming merger with Andromeda. We are not passengers on a separate vessel. We are the vessel itself. We are the galaxy, thinking, questioning, and reporting on itself. If this were a true breaking news broadcast, the tone would be urgent. The Milky Way is in transition. Its spiral arms are warping. Its black hole is restless. Its satellites are falling. Its rival is approaching. The news would not be calm. It would be dramatic, because the truth is dramatic. This is not a stable system. It is a system in motion. But there is also hope in that motion. Every collapse seeds new creation. Every death fuels new life. The Milky Way's end will not be a void, but a transformation, a merging into something greater, a continuation of cycles that stretch beyond imagination. And so, we close this report not with despair, but with recognition. The Milky Way is temporary, but while it lasts, it is magnificent. And while we last within it, so are we. This is the final headline from the galaxy. You are made of stars. You are part of the Milky Way, and the Milky Way itself is part of a universe still unfolding. Breaking news! The Milky Way story has reached its final report. From the beginning, we have traced its arcs, from the faint band of light across the human night sky to the colossal spiral revealed by telescopes, to the hidden skeleton of dark matter holding it together. We have seen its history of violence, devouring smaller galaxies, warping under external pressures, feeding on streams of gas. We have glimpsed its present, slowing star formation, restless black holes, warped arms. And we have followed its future, merging with Andromeda, fading in star-making, dissolving into the silence of the universe. This is the Milky Way's headline. Our galaxy is not eternal, but in its impermanence lies meaning. From its destruction came creation. From its chaos came order. And from its stars came life. You, every breath, every cell, every thought are part of this cycle. The oxygen in your lungs was forged in red giant stars. The iron in your blood was born in supernovae. The calcium in your bones was once scattered as dust through interstellar space. You are not separate from the Milky Way. You are the Milky Way, conscious for a brief moment of its own existence. Like empires on Earth, the galaxy has expanded, consumed rivals, and reshaped itself. And like empires, it too will change, merge, and eventually fade. But no empire on Earth has ever created the raw material of life. The Milky Way has. Its story is not just cosmic, it is personal. It is the story of us. So we end where we began, under a sky filled with stars. To the human eye, the Milky Way is a soft ribbon of light. To science, it is a vast and restless machine. To philosophy, it is a reminder of impermanence. To you, it is home. This has been the final report. The Milky Way story continues, but our broadcast is complete.